Today, I am going to present my topic on stack implementation using linked list. We will walk through the concept of stacks, their operations, how can we implement them efficiently using linked list in C. Coming to slide 2, what is a stack? A stack in data structure where elements are added and removed from only one side. A simple real life example is a stack of plates. When you add a plate, it goes on top, and when you remove it, you also take it from the top. Operations in stack. We can insert elements, remove elements, check the top element, and display all elements. Each operation works at the top, which makes the stack operation simple and efficient. Types of stacks. There are two common ways using arrays and using linked list. Arrays have a fixed size which can sometimes cause limitations. Linked list on the other hand allow the stack to grow dynamically, making them more flexible. That's why we prefer linked list implementation when the size is not fixed. Structure of a node. We define a structure called a node. Each node contains two paths, one to store the data, another to store the address of the next node. In the code, in data stores the value. Struct node next points to the next element. We also maintain a pointer called top, which always points to the first node in the stack. Initially, this is set to null, meaning the stack is empty. The first operation in the stack is push. The push operation is used to insert a new element into the stack. This involves creating a new node, assigning data, and adjusting pointers so that the new node links correctly with the existing stack. Breaking down the push function step by step. First, we declare a variable to store the value and pointer for the new node. Then, we allocate memory using malloc. We take input from the user, assign the value to the node's data field. Now, the important part. We link the new node to the current top using next a new node next is equals to top. Then update top is equals to new node. This ensures that the new element is placed at the top of the stack. Finally, a message is printed confirming insertion. Pop operation. The pop operation removes the top element from the stack. Since stack flow a top based removal, we always remove the most recent element added. First, we check if top is null. If yes, the stack is empty, so we display an underflow message. Otherwise, we will store the top in a temporary pointer. Print the value being removed. Now, the top pointer to the next node using top is equals to top next. Free the memory of the removed node using free. Seek operation is used to view the top element without removing it. This is useful when we only want to check the value but do not want to modify the stack. In this function, first we check if the stack is empty. If it is, we display a message. Otherwise, we simply print the value stored in top is equals to data. No changes are made to the structure of the stack. The traverse code create a temporary pointer and assign it to the top. Then we use a loop to move through each node inside the loop. Print the current node's data. Move to the next node using temp is equals to temp next. The loop continues until we reach null, meaning the end of the stack. Advantages and disadvantages of stack implementation using linked list. It is flexible and uses memory efficiently but also requires extra memory for pointers and is slightly more complex to implement compared to the arrays. To conclude, implementing a stack using a linked list is a powerful approach when we need dynamic size and flexibility. It avoids the limitations of fixed size arrays and ensures efficient memory usage. This makes it highly useful in real world applications where data size is unpredictable. Thank you.